I'm going to demo the JSON document storage features of the autonomous database. To start out, I've got just a single slide where I'll motivate why the autonomous database is a good choice for storing JSON data. After that, I'll create a database and show how JSON can be stored in it using simple collections. And I'll show how data stored in those collections can still be accessed using SQL if you need to. And to end the demo, I'm going to bulk load some JSON from the Oracle Object Store and then show how that data can be viewed and analyzed using a notebook. The Autonomous Database is Oracle's managed database service in the cloud. Here, manage means that things like installation, patching, backups, and tuning are all managed for you automatically. You can create a production-ready database and have it up and running in just a matter of minutes. And this is nice for application development because it allows you to focus more on the app and less on the database. Using JSON as your storage format is nice because it can typically be consumed from applications very easily, and your application can evolve the data to store new types of data without making database-side changes. In general, the Autonomous Database provides a lot of the same benefits that are typically associated with NoSQL document stores. For example, the Autonomous Database is elastic, meaning that you can scale up or down the compute and storage as you need to. You can enable auto-scaling, so the capacity goes up or down based on your workload. We've also seen that NoSQL databases advertise that they can maintain single-digit latency for reads and writes at scale. What this means is that the response time for individual requests doesn't exceed 10 milliseconds, even under heavy loads. The Autonomous Database can also do this. The Autonomous Database can maintain single-digit latency for reads and writes. But it doesn't do this at the cost of durability or consistency. For example, you won't have queries that could return the same JSON document twice just because other users are writing data at the same time. If you read the documentation for NoSQL stores, they typically call out these types of cases. And it seems like it would be difficult to anticipate or test for these sorts of cases, things that might only happen under heavy loads. The other advantage of the Autonomous Database is that it's multi-model, meaning that you can store and query JSON data alongside other types of data, such as relational, XML, geospatial, and so on. And all of these different types of data can be accessed and analyzed together using Oracle SQL. They can even be accessed from a single query. Finally, everything that I'm going to demo works in the always free tier of Oracle's cloud. So you can store JSON in the Autonomous Database for free, forever. You only have to start paying Oracle when you outgrow the storage and compute limitations of the free tier. To start the demo, I've logged into the Oracle Cloud console and I'm going to create a database. I'm going to click on this link here that says Create an ATP Database. ATP stands for Autonomous Transaction Processing. It's the version of the Autonomous Database that is optimized for transactional and operational storage. This next page asks me a few basic questions about the database I am going to create. I'm going to call it DemoDB. And notably, it's asking me about the compute and storage capacity. I'm going to leave all this at the default of 1 CPU and 1 terabyte of storage. But these settings can be changed at any point in the future. I'm going to add an administrative password. And that's it. Now I click Create Autonomous Database. And I'm redirected to this page that indicates that my database is being provisioned. Creating a database typically takes about a minute, but I'm going to go ahead and pause the recording until this database is created. Okay, the database is now available. While the video was paused, I went ahead and created a new database user and connected SQL Developer Web as this user. SQL Developer Web is a way to execute SQL and other commands against the database from a web browser. So the first thing we're going to do is create a collection of JSON documents. To do this, I'm going to execute a SOTA command. SOTA stands for Simple Oracle Document Access. It is a way to work with data in the database as a simple collection of JSON values rather than a table with columns and rows. So first command I'm going to run is soda list, which is going to show me the collections we have in the database. And it says there's no collections because we haven't created any yet. So next I'm running soda create, which is going to create a collection named emp for employees. And so now if I run soda list again, you can see that there's one collection named emp. And so now I'm going to insert a few collections or a few documents into this collection. So the first one is an employee named Blake, who's an intern, and he makes $30,000. So it's the first employee. I'm going to insert a couple more. The second one is an employee named Smith. His job is a programmer, and he makes $80,000. And third, we have Miller, who's also a programmer and makes $90,000. Okay, so now we've got this employee collection, and we have 3 JSON documents in it. So now I'm going to get one of the documents back out. So if I can do a soda get, and I'm going to add a filter. So in soda, you can filter documents that you get back using a query by example. We basically create a JSON document that looks like the data that we want back, and that's used as a filter on the document. So I'm going to write a QBE that specifies I want the documents back where name is Miller. I forgot the emp. And we can see I get back just the programmer named Miller. I can do more complicated QBEs here. If I want to filter by salary, I can use the greater than operator. So here I'm going to pull back employees that make more than $50,000. And so I got 2 documents back, the 2 programmers, but it did not return the third employee, the intern, that makes less than $50,000. So at this point, I'd like to point out that while I'm interacting with my data using this simple collection, I'm free to switch back to tables at any point. If I refresh this table list over here, we can see that now there's an employee table named emp and with the following columns. This table serves as the backing store for my collection data. And at any point, I can use SQL over this table instead of using the collection API to analyze the data that I stored in my collection. And we're going to come back to this in a few minutes. But first I'm going to show you how we can use Soda to access collection data from an application using either REST or Java. Soda collections are supported in a number of different languages such as JavaScript and Python. But today I'm just going to be showing a quick example in REST and Java. So each database comes with RESTful data service access to the database enabled out of the box. And to get the URL of the RESTful services for our database, we can click on the Service console. And in the Service console, we click on Development, and in the lower right-hand corner here, we can see a card titled RESTful Services in Soda. And we can click Copy URL to copy this URL that is the root endpoint for RESTful services on our database. I'm going to take this URL and I'm going to go to a program called Postman. We're not affiliated with Postman, at least that I'm aware of, but I'm just using it as a generic tool to submit REST requests to my database. So I'm going to take the URL and paste it in this box, and I'm going to add some things at the end of this URL. So first I'm going to add the database user that I added that collection to, which is named Josh, and then Soda, and then latest, and then emp. And so this URL now refers to the collection we just created. So I'm going to add one little thing here, fields equal value, and that just tells it that when I do this GET request on this URL, I only want the documents back, not the keys. And I need to specify a username and password. Looks like that's already there. And then I click send, and that's sending a REST request to my database, and we get back the 3 programmers that we added just a moment ago. So next I'm going to insert a 4th programmer into this, or a 4th employee into this collection using REST. So I'm going to change this from a GET request to a POST request, and I'm going to add a body, JSON body. And I'm going to add my 4th employee, who is a manager. Her name is Clark, and she makes $100,000. So now if I click send, I get a response back that indicates that this insert was successful. So this REST API is a full-featured API. It can do query by example, it can do pagination, updates, bulk loading, and so on. I'm not going to go into any of that right now because this demo is intended to be a quick tour. But we plan to do a series of follow-up videos that do a deeper dive into some of these areas. But for now, I'm going to move on, and I'm going to show how we can access the same collection from a Java program. In this example, I have some Java code on my laptop that's going to access the employee collection that we created. In this example, at line 16, it gets a connection to the database. At line 21, it opens the employee collection. At line 24, it does a find on all the values in the collection and then iterates over them in a loop. And at line 28, it's printing out the name, salary, and job of each employee. So if I click this green button over up here, it's going to run this example. And in this bottom window, we can see the output of this program, and we see the 4 employees that we've been inserting so far. In the second example, I have it inserts a 5th employee into our collection. At line 26, it constructs a JSON object for a new employee, the president of our company. His name is King, he makes $200,000, and unlike the other employees, he has an email address attribute. And this is okay since we're using JSON. And there's no server-side metadata that we have to change in order to add this attribute that none of our other values have. And at line 34, it inserts this employee into the collection. So if I do and so after clicking the green button, it runs it, and now this employee is inserted into the collection. These examples are very simpler, but if you would like a more complete example of how you can create a microservice application using Soda and Java, we have MooShop. MooShop is a full example of how to build an e-commerce site in Oracle's cloud. It uses a modern microservice-based architecture. In particular, the shopping cart service uses JSON storage in the autonomous database. All of the code is open source, and you can look at the cart service in GitHub to see one way that you might build a microservice over Soda Java. There are also instructions here on how to clone the app and run it under your own cloud account. So next, I'm going to go back to SQL Developer and show you how you can evaluate SQL over the data, the JSON data that we've stored so far. As mentioned earlier, this collection that we created is backed by a table with the same name, emp. And the table has 5 different columns. In particular, the JSON document column holds the employee data that we've been inserting. And so we can select this data with a select query. So in this query, I'm just selecting the JSON document column. JSON serialize is necessary to convert Oracle's internal binary JSON format into a JSON text that we can read. And after running this, we see the 5 JSON documents that we've inserted so far. But we can also project out the nested attributes in these documents. In this next query, I'm projecting out the name, job, salary, and email as relational columns. If I run this, we see a query result with 4 columns. And there's no restrictions on the types of SQL that we can express over this JSON data. We can do arbitrarily complex joins and aggregate queries. This next query does a group by on the job title. So we see that we have 1 intern, 1 president, 2 programmers, and a manager. For the final part of this demo, we're going to take a more complex and interesting public JSON data set, and we're going to upload it to Oracle's object store, and we'll show how that data can be bulk loaded into a collection, and then how we can generate a machine learning notebook report over that data. So the public data set that we are going to load comes from City Bike. City Bike has bike sharing stations across New York and New Jersey. We aren't affiliated with City Bike as far as I know, but they've done a nice job of publicly exposing JSON data about the 900 bike stations that they operate. We're going to upload their data into the Oracle Object Store and then bulk load it from there into a JSON collection. Specifically, they have 2 data sets that we're going to upload. The first, on the left, contains information about each station, including its name, its location, its rental capacity, and so on. The second dataset on the right contains point-in-time information about the station, including how many bikes are currently available to rent. That is, each record in the first collection has multiple joining records in the right, and the ones on the right represent multiple points in time for that station. I've got these data sets as 2 files on my local computer, where each line in a file represents a single JSON document record. So we're going to take these files and upload them into the Oracle Object Store. Now we're back in the Oracle Cloud Console, and I'm going to enter object storage. And the first thing I'm going to do is create a bucket to hold this data. I'm going to call it bikes. And I'll select the bucket I just created. And I'm going to make this a public bucket, since it's a public data set. Now I'm going to upload these 2 files to the bucket. And it'll just take a moment for the 2 files to upload. Now we can see in this list the 2 uploaded files. If I go and click on the details of one of those objects, I can see the link that corresponds to that file. And this is the link that we'll use to bulk load this data into a JSON collection. So next we're going to go back to SQL Developer and issue a PL SQL call to load this data into the collection. So we're going to call the copy collection procedure to load the data from these files into JSON document collections. The first argument to the function is the collection name, and it will create this collection if it doesn't already exist. The second argument is the file or files in the object store that are going to be loaded into the collection. And the third argument is a format object that tells it information about how the data is structured in the file. And so we've called this function twice to load these 2 files into 2 different collections. And so now if I run the select count stars, I can see that I have 939 documents and station information. And I have 20,000 documents in station status. So we're going to write a SQL JSON query over these collections. And so this query is going to select the station ID, the station name, which it gets from a join between status and information, the min number of bikes available, the max number of bikes available, and the average number of bikes available during this period. So if I run this query, I can see the data below. We've got the station name, the min, the max, and the average. And so we're going to take this query and make a Oracle Machine Learning notebook report over it. But before we do that, we're first going to define a view based on this query so that when we get there, we don't have to retype all this. So this is the same query you just saw, but I added a create view so that I can refer to it as station stats. So if I run this, it tells me the view was created, and now I can just do a simple select star from this view, and I see the same data as before. So next we're going to go into Oracle Machine Learning notebooks and create a report based on this data. So you can get to Oracle Machine Learning notebooks through the Service Console. So you click on Development, and click on Oracle Machine Learning Notebooks. That takes you to this screen, and I'm going to click on Run SQL Statements. So in this window here, I'm going to run a simple select query over the view we just created. And there we see a table like we saw before. But I'm going to refine this a bit to just select the name, the min, and the max. Running it again. There we see it, and this may look better on a bar chart. But I'm going to put both the min and the max in this bar chart. And this is a lot to look at. And so maybe I'm just interested in the stations that had a lot of activity. So I'm going to add a where clause. And I'll say where the max is greater than 25. So at some point it had more than 25. That helps a little bit, but it's still a lot of data. So I can add more selective predicate. And so that helps. Now we're down to just 6 stations where the minimum and the maximum available during this period was different. So this concludes our tour of the JSON facilities in the Autonomous Database. With our service, you get the best of both worlds. You get simple and flexible application development using JSON collections, but you don't lose the ability to use SQL over the data when you need it. You get elastic storage and compute to handle demanding operational workloads while still being able to support analytics over your data in real time. What we've created here is really unparalleled in the industry, and I hope this demo encourages you to give it a try. You can go to cloud.oracle.com/free and create a database right now and try what you saw here. There's no strings attached. It will ask for a credit card to verify your identity, but it's not going to charge your credit card unless you explicitly go in and upgrade to out of the free tier. There's not any sneaky automatic charges that kick in after a time period or anything like that. It's really just free. So please give it a try. And thanks for watching.